Hello, and welcome to another Into the Terminal Dark Mode. Today we're going to talk about managing containers.
Oh, hi. Is this seat taken?
Hey, what are you doing here?
What are you doing here?
It's Boston.
Yeah.
We're blessed with Eric in the house for Dark Mode. Who'd have thunk it?
Yeah, who'd have thunk?
So you want to take over MC?
Sure.
All right.
I'll take the con. All right, containers. Why don't you kick us off?
All right. So for our critical path, we're going to talk about listing the images in our local repository and running a container out of our local repository. So the command that we're going to work with is podman. And to list what's in our current local repository, we're going to do a podman images. And so we can see that there is one image currently there, rhel-9-HTTPD. And to run it, we're going to do a podman run. For this, we're going to do an interactive run, meaning we're going to have the container spin up and we're going to have a program run in the container that we interact with. So I want to run a copy of rhel-9-HTTPD. And the interactive program I want to run is bin bash. So the shell that we're looking at is within our container runtime, and we can verify that by looking at some of the stuff that's in the container. So what might tell us that we are in a container image, Eric?
So just barely, if you look at the file system layout of a container, it's just slightly different than if we had a host machine. So if we did, say, a df-h, we'd actually notice, and one of the things I want to point out is this /dev/shm. That's actually short for shim. I don't have a good quick way of explaining what a shim is, but it's basically sits between
shared memory.
Shared memory?
Yeah.
I was overthinking.
The other interesting things are, notice that our slash file system is an overlay.
Mm-hmm.
So what happens is our initial content of our container is spun up, and then any changes that happen to our container contents is stored as an overlay on top of the files of its original image. And we could choose to then like snap a copy of it and persist it again. But if we get rid of this container, we just throw away all those changes by ditching the overlay. And then the other thing in here is tempfs. So like everything in here screams temporariness, and that is one of the things that tells me I'm looking at the container image on the inside. We can also look and see that this actually does have Apache installed on it. So if I do an ls-l of user sbin httpd, we can see that this file exists inside of my container. I'm going to toggle my tmux session to be that top window, which is the host that we're running this container on. So Control B up arrow. And if I do an ls-l on user bin httpd, right, there's no such file or directory on the host. So that file is provided inside of this container image, inside of the container runtime that we spawned.
Now, you could be hiding something up your sleeve. Is the HTTP package installed on the host?
Well, let's just make sure there's nothing underneath my sleeves.
Don't make me call shenanigans.
If we do a DNF list HTTPD, it's going to go out and look at the content available, and notice that right here there's no @ in front of this repository name, which tells me that this is an uninstalled package on the host. So I could install it, but we're going to stick with what came with our container.
So I think to wrap up the critical path, we want to be able to demonstrate what is running on the host from a container perspective, and we can do that with a podman ps command, and that'll tell us that we are actually using heuristic McLaren is the common name. We had some good ones this morning for the HTTPD container image that we were running interactively in that bottom pane.
Yeah, so the difference between podman images is those are our available containers that are can be spawned into unique runtimes. Podman PS shows us those containers that have been made into running containers on the system.
So as you can see, Scott and I are together in person. This is actually the first time he and I have met, despite working for each other, despite working on the same team for the past year. So it's been a fun week, and we'll have some updates at the end of the show. But maybe since we are here together in person, we thought about maybe diving a little bit deeper into how containers work. What is a container? What is Podman? And maybe just have a little bit of a discussion before we do maybe some cool things with our own Podman container.
All right. So a container, if you think about it, is really just an archive format. When you're building a container, you're making a archive of a whole bunch of files and content. So this is not that much different than something like a tar archive. So, you use tar command to put files into a tar archive. You use tar command to pull files out of the tar archive. With containers, we're going to use some commands to put files into our container image. And then we use programs like Podman to run the container to access that content once we've distributed it.
What's great is that, especially with like the temporary file system that we talked about, it actually gives you the ability to almost literally copy paste the exact same container and use it over and over and over again. And so if you have a container host that's running multiple web servers, and like we saw with the first example, we actually bound port 8081 on the container host to the port 80 within the container. So as far as Apache within the container is concerned, it's running on port 80, but you can actually have dozens of web server containers running on a single host. You just map them to a different host port, hide those behind maybe a reverse proxy or like an Nginx server to redirect traffic bound for a certain location to a certain container port, which then gets translated into the actual container image or the running container instance itself.
Well, why don't we do that?
Let's do it.
All right. So if I do a Podman, and we're going to change our Podman run command this time, we're going to run it in detached mode, not interactive mode. And Eric, you said that we wanted to bind port 8081 to port 80 of the container. And 9 HTTP. That's the container image that we want to make a copy of and run. All right, so that one's running. And we could do another one. How about we also bind port 8082 and 8080?
Let me guess, 7.
I was going to go with 3, but okay. And so what we've set up is that inside our container, Apache is listening inside the container on port 80 because that's the standard configuration of Apache. But on the container host, we've made it so that when connections come in on port 8081, 8082, or 8083, it'll go to one of these 3 containers. And we can check that out by doing something like a curl. Curl. So port 8081, right? There's my Apache test page. Actually, it's a Nginx test page.
Nginx, interesting.
Yeah.
Oh, it's got both trademarks in there.
Oh, nice. 8082, right? There's another test page, and 8083. That's my 3rd container test page. And we could do something like connect to the containers and change maybe their index HTML so that each one of them could show differently. But that was a great idea I had just now instead of before the show.
That's true. We do our best work on the fly. Oh, what else do we want to talk about? Actually, do we want to do a Podman PS so we can see all of these containers running sequentially here?
Absolutely. So there's our 3 different containers. You can see their port mappings as well. And then our favorite thing is the human-friendly name? Vigorous Vaughn, Suspicious Keller.
Yeah, Keller, if you're out there, you're very sus.
And Hardcore Blackburn.
You can tell we have not slept much this week.
So each of these containers is assigned not only a unique container ID, that's this hexadecimal value right here, but because unique hexadecimal IDs are sometimes difficult to type or remember. We also give it this other more human-friendly name, which we can use for referring to this specific container runtime that's executing on the machine.
You can actually see those right behind us too.
Indeed.
So what if we wanted to take this a step further? We talked about having temporary file systems. We talked about being able to take the same container image and duplicate those over multiple ports. But what if I wanted to go a step deeper? What if I wanted to build my own container? Do we have a tool that helps us do that?
Yeah, so we could use Podman for that as well. But it turns out that Podman is really just a meta utility that calls other utilities. So here at Red Hat, we call those the rhel-container-tools, and it's a group of, I think we're up to 5 tools now. So Podman actually manages the running of containers. So Podman run is a native to Podman function. Podman build actually calls a subtool called buildah, which is what I'm going to use to build my container. We have Scopio, which is for sharing and inspecting. So if I did a Podman inspect, it would actually call Scopio to do that work. Who's the other one? There's Udita, which is our container tool for making customized SE Linux policies for containers that apply to a specific container label. Oh, and the last one is Cryu, which is container something in user space. It's not restore. I can't remember, but basically it allows you to like freeze a container in its current state and then snap or make copies of it and spin it back up in the same state, either on the same or different hosts.
So if I want to use buildah then to create a new container, one of the other things that Red Hat has started doing is created basically a template, if you will, for basically creating a template that you can build off of. And we call those UBI images, universal base images. And if you think about it, it's basically a Podman container with rhel stuffed inside of it. For the standard sized UBI image, you've got a lot of the same operating system utilities that you're used to working with on your on a container host, things like VI or DNF. And there's others that are smaller that you can actually use the buildah tool along with Podman to inject packages or tar files or something into a container image. And we call that UBI, Universal Base Image. So there's UBI containers for rhel 8 as well as now rhel 9.
And 7.
And so I forgot about 7.
Yep. So if we're going to build a fresh container, we can either choose to build it from scratch, meaning we're going to make that entire container file archive from zero. Or we can use a base image like the Red Hat UBI so that a bunch of stuff is already in there, and then I'm just supplementing the existing things with my content, right? So I might take the UBI and maybe install a couple of extra packages on it that I need for my application. I might pull down content from GitHub into it because that's the actual like JavaScript or whatever that makes up my application. Or I might change some configuration files in it. And then once I've got all my content positioned, I'll make a new image that I can then spin up as many copies of as I want with Podman.
Okay, why don't we do it?
All right, so let's do a buildah. Right, so again, we could use Podman build. The syntax is slightly different, but I like using the tool natively because it does some nice things automatically for me. Buildah from, and then we tell it where to grab our initial container image. We want registry access.redhat.com/UBI9 UBI. I think that's right. Yeah. So it goes and accesses the registry and then tries to pull a copy of the image. So here we see it actually like transferring the image contents. And if we do a Podman images, right now I have 2. I have that rhel 9 HTTPD. Oof.
Not the only one who screwed that up tonight. I feel better now.
that we were using earlier, and then now we have the UBI image that we pulled down. But I want to call your attention to this last bit of our buildah from. So one of the reasons I like using buildah natively with buildah from is because it will not only pull down the container image, but it'll also mount it into my directory tree so that I can access it to put content in it. If we did this with podman pull, we could download the image and then we'd have to like figure out where it was stored and mount its container image into our directory tree, and buildah from just does all of that work automatically. So what should we put into our new container image that we're building?
Well, our earlier example covered HTTPD, so why don't we start there?
All right. So we're gonna build a run, and we're gonna run this in UBI working container. And then on the other side of the dash dash are the actual commands that we want to run inside our container. So we want to install something. So we'll do a DNF install -y HTTPD. Right. And what we're going to do is when we're running this DNF command, it's going to be running inside of the change rooted environment of our container image. So as it's flinging user sbin HTTPD into the directory tree, it's doing that underneath this constrained directory structure of our working container.
So to demonstrate that, why don't we look at the host system and see if that user sbin exists?
Yeah. So we'll do two things. One, we'll look at the container image, and then we'll also look at the host itself.
Perfect.
All right. So we can see that it's installing things, and we're going to do an ls-l on the host, user sbin HTTPD. No such file or directory. But if we build a run, so again, it's going to run that command inside this change rooted environment of our UBI working image. We can see that that file does exist inside of our container that we're building. So at this point, we can do things like a buildah run in the UBI working container, a git pull to like pull some stuff off of GitHub or GitLab. We could edit a file or use sed commands to make changes to existing configuration files that are stored down in there. So at this point in the buildah section, we're making all of the changes that we want for our final container image. And there's another way that we can do that too, right, Eric?
Mm-hmm.
Like, how would we automate it?
Oh, I didn't pick up.
Oh yeah, there's another way. Sure.
Sorry, I lost my train of thought there. What was the question?
So we've been doing this all by hand, individually running commands.
Oh,
but
right.
we could like make a thing that would do this more automatedly to build our container.
So, and I actually brought this up on the morning stream, but one of the other ways that you could do this is actually using a Docker file, and not like a Docker file, but Docker file. It is an actual term. There's an actual type of file that you can use to define Docker images. Actually, I think there's a Podman file as well.
It's called container file.
Container file. But it's basically a list of operations that you can execute as the container image is being built. So think of it as a layer cake. If you want to do, like we did a buildah from inside that container file, you can do a from UBI /UBI9. And then do a DNF install, do a DNF update, so you get all the latest security patches within your container as you build it. I could see also using the same setup, the same process, if you have some sort of like a PHP application was one that I had to work on as a sysadmin. And there were certain additional packages. You had your core PHP library files and language files and that kind of thing, but you'd also have additional like plugins and that kind of thing. And depending on the type of application that you're running, you need them here, but maybe not in this other application. So it would have been really nice to say, oh, you need XYZ application with these PHP plugins installed. Great. Let me just pull down UBI, which gives me all the security functions, all the stability and everything that you're used to when running rhel, and put that inside of a container and couple that with the customization of your application. And so what we'll do next is we'll actually, buildah can actually do a commit, which will allow us to then save this image that we've worked on as a unique container image. And we'll actually, why don't we do that before I finish my train of thought? Let's go ahead and do a buildah commit.
So before we do that, I did want to just tag in a couple of things there.
No, absolutely not.
So in a previous episode, we talked about shell scripts, right? And at their very basic level, a shell script is a series of commands that one executes on a system. And that's really what we're talking about when we talk about building a Docker file or a container file. It's all the steps that we just did manually: pull the image from a registry, install this extra package, make any tweaks to the contents. Like, we just put that into a container file, and then it will just execute that list of commands in series. And then when we're done with it, we do a commit. So buildah commit UBI working container. And let's see, we're going to call it there you go. Eric's cool stuff.
That's even better than this morning. This morning it was Eric's container.
You said it wasn't descriptive enough.
It's true.
All right. So how can we see if our new container image has been created?
So this is why I cut myself short, because now that we've created a container image, you might remember at the top of the show that we already had a rhel-9 HTTPD. So now if we do a podman images, we can see what images have been pulled down locally onto our host. So you notice that we've got the rhel-9 HTTPD. Good grief. Apache, change the name of that, please. So we've got that one from the start of the episode. We've got the rhel-9 version of the UBI image, the UBI 9, and then we've got Eric's cool stuff container as well. So now we've got all three of those. So notice something else worth noting is you can actually build customized container images on top of existing container images. So you don't have to go in and create basically your own fork of UBI and then add your stuff on top of it. It actually, it calls it down as a dependency. So I need UBI 9, and then I'm adding these additional things on to create the Eric's cool stuff podman image.
Yeah, and we can run it. We actually didn't set it up to run detached. So we're just going to run it interactive. There's a lot of other stuff we got to do there, but maybe we'll do it in a follow-up episode. All right, so let's do a podman run IT for interactive. Eric's cool stuff. Oh, I didn't tell it what to run. Oh, but it ran the bash command anyway, because that's the assumption. Cool. So again, we can look at maybe something like df, right? And we see that this is our overlay file system and everything's stored in temp. And if we look at user sbin HTTPD, right, there's the RPM that we installed in it earlier. So,
and if we go up to the top pane, we can actually do a podman PS. I think we're up to like 5 running containers now.
We are. And here's the last one, Eric's cool stuff.
Friendly. I'm not even going to try that on air.
Graf Hendyke.
That's what I got. But
I mean, that sounds friendly.
Not at all.
Tell someone you love them today. Or do it in German because it's completely terrifying.
Oh, goodness. So we did a podman run. Is there anything else we want to demonstrate?
Let me check the show notes.
That was the end of our list. But
yeah, I think that's about it. I did want to point out if we exit the container, Control B down, it'll no longer show up in our podman PS output because it's not running. However, it's still there. If we do a podman PS -A to show me all containers, there it is, and we can see that it was exited, right? And it keeps its ID and human-friendly name. The other thing that we did this morning that we didn't do here was we showed how the processes are actually running on the host OS.
Oh, yeah.
So, we still have these, 3 other HTTPD containers running. And if we do a PS AUX pipe into grep square bracket HTTPD, these are actually all of the processes running from these 3 containers. So remember earlier we talked about how it's really just a container is an archive of files. So what happened was we used Podman to invoke that that container image, and it used the file for HTTPD executable in the container to run it outside on the host OS. And then it did some other stuff to make sure that like containers couldn't mess with other containers or with resources on the host. But yeah, there you go.
So I thought you said your dark mode crew had a lot of like difficult questions.
Have we heard from Eighth Doctor yet?
No, Eighth Doctor ditched us today. I'm kind of disappointed.
Well, there you go. But yeah, usually there are all kinds of deep thought questions.
We had a comment about learning how to set up a reverse proxy, but as
Chrome died.
well, good thing we got through the demo. But as Iron Sysadmin can attest to, Nginx reverse proxies and I do not get along. So I am not the one to help demonstrate how to set up a reverse proxy. But that might be some content we could at some point. Actually, LS, I don't want to say that out loud because I might screw it up. But anyway, one of the folks in chat helped us piece together what CRYU stands for.
Oh, checkpoint restore in user space. Thank you. That is correct.
So thank you for tracking that down. It took me a while to have a minute to check on it, but thank you for putting that in the chat. Here we go. Here's a question for tonight. Do the containers have an artifact similar to RPMs that you can use to create a local registry?
So the container image itself is the artifact that gets generated. So when we look at a Podman images, right? These are the images that we could then export or upload to a container registry that someone else could then download on their machine. So if we wanted to share something, we'd share Eric's cool stuff, and that would take all the stuff that we already baked into Eric's cool stuff with that that buildah commit and send it all as one unit to someone else to download and run on their system.
In fact, that artifact can be uploaded to Docker Hub or maybe a private repository on Quay.io. You can have local container registries. I know GitHub and GitLab have container registries built in, but that's how those containers, how those container images actually get produced. One of the ways. The other way is a container file.
Yeah, and container file is more to just like, that's what you'd put in your CI/CD work, so that you can, at a specific point in time, execute your series of steps to make your new container. So it's probably a little too much depth on UBI, but we by default rebuild UBI images every 6 weeks. So if you ran your CI/CD pipeline every 6 weeks, you'd pick up the latest UBI with all the updates, and then build all your custom stuff into it, and then you'd be good to go. We actually did a level up hour on configuring Podman and systemd to do automatic container updates. And so if you're interested in doing that, that would be, I went through a pretty in-depth example of making that happen and triggering it and showing how it works.
The Podman auto timer is really cool. So that brings us just about to the bottom of the hour. So I figured I should do this in person, but if you missed the announcement last week, this is actually our last episode of Dark Mode.
What? You're canceling Dark Mode? We didn't get enough likes and subscribes.
The host didn't want to do it anymore. No, we actually put out a Twitter poll a week or two ago, actually longer than that now, and it was unanimous that the current time slots were not working for all of you as a whole, and it was kind of tough on Scott and I, considering this is just something we do as part of our day job and isn't our primary deliverables for our day job. So we put out a poll, and so we have elected to move dark mode, or to move into the terminal, to Fridays at 12 p.m. Eastern. So right around lunchtime on Friday. and we're going to, as a result, we're going to spin down dark mode because apparently Scott has things to do, like family things on the weekend. I don't know. So we're going to move into the terminal off of Thursdays. It'll be Friday at 12 Eastern. Follow us on Twitter to make sure you get all the to get the updated information. Tonight was our last episode. We wanted to do one more since we'd be together in person. Next week, July 8th, 12 p.m. Eastern. And actually, ironically enough, we talked a lot about TMUX tonight. So our next episode is going to be about how to use TMUX, why you'd want to use TMUX, and what exactly is a terminal multiplexer.
Awesome. I do want to thank the denizens of dark mode for joining me for, 3 months of dark mode episodes. It was a great experiment. And what we learned was that people in far-flung time zones across the world don't attend dark mode, but West Coast US people do. So we moved our day show to be in a more, hopefully, West Coast appropriate time slot. There you go. Thank you, guys.
Thank you guys very much for joining us. This has been a look at containers. So on behalf of Scott McBrien and myself and the entire Red Hat Enterprise Linux team, we'll see you next week.